Dear student, welcome to the PPT class. Here, this is Mahbub, lecturer in chemistry, EMDS, Rajuk Uttara Model College. The contents on which I would like to deliver my speech is Chapter 7. The name of the chapter is Properties of Matter and External Effect of Class 6. So, dear student, first of all, if you want to know about any chapter details elaborately, you have to overview the key points of the chapter. So these are the key points of the chapter. The key points are matter, first of all, types of matter, solid, properties of solid, liquid, properties of liquid, gas, properties of gas, differentiate among three states, liquid has no definite size, its explanation, gas has no definite size and volume, its explanation, effect of temperature on three states of water, its explanation, metal, properties of metal, aluminum can be used for cooking, its explanation, explanation of thermal conductivity with experiment, explanation of electrical conductivity with experiment, and some definition. You must have to know this definition. And finally, at the end of the class, I will discuss about cooling with experiment. So these are the key points you must have to know if you want to know this chapter elaborately detail, and all of the topics are very important for your next exam. So, dear student, at the very beginning of the class, I would like to say something about matter. What is matter? Any substances that have mass and takes up space by having volume are known as matter. So, any substances, if it wants to be a matter, it should have mass. Again, say it should have mass and it should take up space. Again, say it should take up space. 2 points is very important. It should have mass and it take up space. Then we can say this substance is a matter. So crockery, clothes, toys, stones, water, chair, etc. all of them have mass and can take up space. So all of them are the example of matter. Dear student, in this slide I would like to discuss about types of matter. Basically, based on the state of matter, matter can be classified into three groups, and these are solid, liquid, vapor, or gas. So in this slide, I would like to say something about solid. What is solid? A solid is a state of matter characterized by particles arranged such that their shape and volume are relatively stable. The particles of solid tend to be packed together much closer than the particles in gas or liquid that causes their rigid shape. So, dear student, if you want to know about solid, in case of solid, basically the particles are arranged in such a way that their shape and volume should be stable. Again, say the particles should be arranged in such a way that their shape and volume should be stable. This is basically just because of the particles of solid tend to be packed together. This is basically just because of the particles of solid tend to be packed together much closer than the particles of gas or liquid. So I hope you understand this topics. The example of solid is mustard seed, boiled rice, stone, toy, banana, etc. Among them, mustard seed, boiled rice, banana basically are the example of less rigid solid. So now properties of solid. The first point is a solid body has a definite size. We know very well each and every solid body has a definite size. The second point is, as all the solid bodies occupy space, they all have volume. We know very well each and every solid body occupies space. As they occupy space, they should have a specific, a constant volume. Now the third point, it is highly rigid. That is, it has rigidity. So the size and volume of a solid body cannot be changed easily. We know very well most of the solid body are rigid and they have rigidity character. And for this reason, you cannot change the size and volume of a solid body. Now the fourth point is the most of the solid bodies have thermal conductivity, electrical conductivity, flexibility, elasticity, plasticity, etc. properties. These are really very important properties in case of solid. Now the fifth point is they have higher melting or boiling point. We know very well each and every solid body has a higher melting or boiling point. So liquid. A liquid is a state of matter that is able to flow. Again say, a liquid is a state of matter that is able to flow and takes the shape of the container where it is kept. Basically, this is a special criteria of liquid. It can take the shape of the container where it is kept, but it retains its volume. So the examples of liquid are water, milk, etc. In case of water and milk, we know very well it can take the shape of the container where it is kept. So in case of liquid, the size of the liquid is basically depend on the size of the container. It can be changed based on the size of the container. So, dear student, now properties of liquid. The first point is a liquid has no definite size. We know very well liquid has no definite size. The second point is it holds the size of the container where it is kept. Again say it holds the size of the container where it is kept. It has already discussed. Now the third point is liquid has a definite volume. Though it holds the size of the container where it is kept, but it retains its volume. That's why in case of liquid it has a definite, a fixed, a constant volume. You should remember this point. And now the fourth point is liquid has no rigidity like solid body. It has no rigidity. Now the fifth point is the volume of liquid is independent of pressure. By applying pressure, you cannot change the volume of the liquid. So you can say the volume of liquid is independent of pressure. So now about gas. What is gas? Gas is a state of matter where intermolecular distance among the particles is so high that particle can move freely or easily and they have no definite size and volume. So dear student, in case of gas, intermolecular distance is so high and intermolecular attraction in case of gas is very lower, and that's why the particles of gas can move freely easily, and for this reason they have no definite size and volume. We can consider the example of vapor, oxygen, carbon dioxide, etc. So dear student, in this slide I would like to say something about properties of gas. The first point is gas has no definite size and volume. Among the three states of matter, gas has no definite size and volume. You should remember this point. And now the second point is they have lower intermolecular attraction, and third point is they have higher intermolecular distance. And due to this reason, they can move freely. You know very well. Now the fourth point is by applying pressure, both size and volume of gas can be changed. So you should remember this. By applying pressure, both the size and the volume of gas you can change. So both the size and volume of gas cannot be independent of pressure. So you should remember this point too. So dear student, in this slide, I would like to say something new about how can you differentiate among three states of matter. This is very important slide, so you should notice this slide carefully. The first point is basically based on the size and volume to differentiate among three states of matter. So in case of solid body, it has both definite size and volume. Again say, in case of solid body, it has both definite size and volume. In case of liquid body, it has no definite size. It holds the size where it is kept, like container. I have already discussed this point for a number of times. Again say, liquid body has no definite size, but it retains a specific, a constant volume. In case of gaseous body, it has no both definite size and volume. Now the second point to differentiate among three states is basically based on the how much packed the particles of the matter. So in case of solid body, the particles are so packed, and that means they are very closer to each other, and that's why they are solid. They have higher melting or boiling point, and they show number of properties. In case of liquid body, the particles are not so packed like solid body, but they are so packed comparably than gaseous matter. In case of gaseous matter, intermolecular distance is so high and intermolecular attraction is so lower, and that's why the particles can move easily, freely. Now, the third point is basically based on the example. The example of solid body can be stone, toy, chair, etc. And in case of liquid body, example can be milk, water, kerosene, etc. And in case of gaseous body, it can be vapor, oxygen, nitrogen, carbon dioxide, etc. So in this slide, liquid has no definite size. I would like to discuss or explain this point, this question. Actually, I have already discussed this point for a number of times. Again, I say a liquid has no definite size. It holds the size of the container where it is kept, but it retains its volume. Thus, depending on the size of the container, the size of the liquid changes. So this is basically depend on the size of the container, but volume retains constant in case of liquid, you know very well. But it can be said that liquid has no definite size but has a constant volume. So, dear student, in this slide I would like to explain gas has no definite size and volume. To explain this question, just you think of two cylinders where one is small and another is large. If anyone keep the same amount of gas in both of the cylinders, the gas will occupy the space whole area of the small cylinder as well as the large cylinder. So it can be said, if same amount of gas is kept in small cylinder, its volume will be small. If same amount of gas is kept in large cylinder, its volume also will be large. So volume of gas, again says, so volume of gas basically depends on the volume of the cylinder. Again say, volume of the gas basically depends on the volume of the cylinder. So it can easily be said, gas has no definite size as well as it has no definite volume. Now effect of temperature on three states of water. When a piece of ice is kept in a pot, what happens? It is converted into water due to the effect of room temperature. Again, it is possible to convert water into vapor by heating it up. And by reducing heat, vapor can be converted into water. After cooling water at 0 degrees Celsius temperature, it can be turned into ice. So it can be said that temperature has great effect on the three states of water. If you want to convert ice into water, you have to apply heat here, and if you want to convert water into vapor, you also have to apply heat. And if you want to convert vapor state to liquid state, water state, then you have to reduce heat here. And if you cooled water at 0 degrees Celsius temperature, then water will turn into ice. So the three states of water you can convert easily if you just change the temperature. So temperature has a great effect on the three states of water. Now, a metal is a material which is typically hard, shiny, malleable, or ductile. Again say, which is typically hard, shiny, malleable, or ductile with good electrical and thermal conductivity. The example of metal can be iron, gold, aluminum, etc. Now the properties of metal. The first point is based on state. Metals are solid at room temperature with the exception of mercury. We know very well the state of mercury is liquid. Now the second point is luster. Metals have the capability of reflecting light from their surface and that's why they shows a lustrous appearance. The third point is malleability. Metals have the capability to withstand hammering and can be made into thinner. It can be converted into thin sheets. And for this reason, they have malleable properties. Now, the fourth point is hardness. Metals have the most of the metals are hard, but some are soft and or brittle. This example, sodium is a soft metal. Ductility. Metals can be drawn into wires. It can be converted into wires, and this is the ductile properties of metal. Conduction. We know very well metals are good conductor of heat and electricity. In case of electricity, we can consider the example of copper, and in case of heat, we can consider the example of aluminium. Now, aluminium can be used for cooking. Why? Aluminium pots can be used for cooking in our day-to-day life because aluminium is a metal. We know very well it can transmit heat from the oven fire to the main ingredients. Again say, aluminium can transmit heat from the oven fire to the main ingredients of cooking, say rice, fish, etc. And thus the ingredients get boiled due to this heat. Hence, aluminium metal can act as a good conductor of heat. A question can arise here also, metals are good conductor of heat. For this question, the answer should also be same. So we can go to the next slide. Now, explanation of thermal conductivity with experiment. The required accessories is 1 spoon of glass, 1 spoon of plastic, 1 spoon of aluminium, 3 1 taka coins, 1 beaker of 60 ml, 30 ml water, a spirit lamp, wax, safety matches and stopwatch. First of all, make the wax soft by heating it moderately. Add a little soft wax on the handle of each spoon. Now place the coins on the wax with pressure. Now take about 30 ml water in the beaker and put it on the spirit lamp. Now immerse the 3 spoons in the beaker by holding them with threads in such a way that the coins stay outside the upper portion of the beaker. From which spoon do the coin get separated first and from which it haven't last of all? Please notice it carefully. Undoubtedly, the coin on the aluminum spoon is separated at first because the aluminum is a good conductor of heat. So heat from the hot water in the beaker reaches the wax of the aluminum spoon comparatively faster through conduction. As a result, the wax melts down and the coin is separated. So it can be said through this thermal conductivity experiment, it is clear metals are good conductor of heat. Aluminium is good conductor of heat. So, dear student, now explanation of electrical conductivity with experiment. In order to understand electrical conductivity, please look at the figure, please. Here, one electrical cell, say battery, is used, and an electrical bulb is also used. The wire which is used here is made of wire. After completing this circuit, what do you see? The bulb is illuminating As copper is an electrical conductor, it transmits electricity taking from the cell and send to it to the bulb. Again say, as copper is an electrical conductor, it transmits electricity taking from the cell and send it to the bulb. For this reason, the bulb lights up. If the copper wire was not an electric conductor, it could not conduct electricity and the bulb would not light up. So from this experiment this is clear, metals are good conductor of electricity. Now dear student, we will discuss some definition. What is rigidity? Rigidity can be defined as the inability of any material to be bent or changed its shape. I hope you understand. Rigidity can be defined as the inability of any material to be bent or changed its shape. Now flexibility. Flexibility can be defined as the ability of any material, again say the ability of any materials to be bent or changed its shape easily without breaking. Now volume, the space occupied by a body is called its volume. The space occupied by a body is called its volume. Now melting point, the temperature at which a solid body starts to melt. Again say the temperature at which a solid body starts to melt. It's called melting point. The melting point of wax is 57 degrees Celsius. Now boiling point, the temperature at which a liquid body starts to vaporize. Again say a liquid body starts to vaporize. It's called boiling point. The boiling point of water is 100 degrees Celsius. Now the freezing point, the temperature at which a liquid body starts to become solid. Again say a liquid body starts to become solid. It's called freezing point. The freezing point of wax is 57 degrees Celsius. You should remember the melting point and freezing point of any substance should be same. So at the end of the class, the last topic is cooling. Cooling is the process of changing the liquefied wax to solid. Again say this is the process of changing from liquefied wax to solid. It's called cooling. So finally, I have completed my class, my lesson. So dear student, from through this lecture, I try my best to give you some information, to suggest you some information, which information are is really very important for your next exam, and it will be helpful for you. And finally, as the condition of the whole world is not so good due to the coronavirus effect, all of you should stay at home, and I hope all of you should stay at home and be safe. All of you should pray for me, and I also pray for all of you. And so Allah Hafiz, be well and stay at home. Thanks to all.